Okay, Mr. Harmless here, and we're going to do the notes for 7-1. Okay, 7-1, dilations. Dilation. So, dilation is the enlargement or reduction of a figure. So we're making it bigger or making it smaller. The way that we know how much bigger or how much smaller it is called the scale factor. Okay, so I'm telling you these words because you need to know these words, right? The variable for the scale factor, we're going to use the letter K for all of our purposes. This entire chapter, if I'm talking about the scale factor, I'm going to use a letter. I'm going to use the letter K. When K is bigger than the number 1, it's going to be an enlargement. When K, the scale factor, is smaller than the number 1, it's going to be a reduction. Okay, so that's how you do an enlargement or a reduction with dilations. Okay, let's take a look at what this looks like. Here you have triangle RST with these vertices. So first of all, I'm going to plot this. R, negative 5, 1. So 1, 2, 3, 4. So negative 5, 1. Put it in the wrong spot. Do that. Negative 5, 1, up 1. That's point R. S, negative 3, 4. 1, 2, 3, negative 3, 1, 2, 4. There's point S. And point T is 2. 2, negative 1, which is right there. And there's point T. Then we're going to connect those dots. So we've got R, we've got S, and we have T. And there's our original shape. Now I'm going to switch to red to represent this right here. Notice the scale factor is 2. That's bigger than 1, which means it's an enlargement. It's going to make this larger, okay, a bigger triangle. Here's the nice thing. It's going to make it exactly 2 times bigger. So this is going to be really easy, actually. All you're going to do is you're going to look at these points, and each one of these numbers you're going to multiply by, guess what? 2. Negative 5 times 2 is 1 times 2 is negative 3 times 2 is 4 times 2, and then T, 2 times 2, and negative 1 times 2. Now if I plot these, it's going to make the same triangle except twice as big. So my new point R prime is what we call that. My new point R is negative 10, 2. So negative 10, 1, 2, 3, 4, 5, 6, 7, 8, negative 10, 2. There's my new point R. My new point S, negative 6, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 7, 8. There's my new point S, S prime. And then my new point T, T prime 4, negative 2. 1, 2, 3, 4, negative 2. There's my new point T, T prime. And then we'll connect those dots. So R to S, S to T, and then back over here to R. Notice it's the exact same triangle, just twice as big. Okay, this is called a dilation, and this particular dilation is an enlargement. Okay. The nice thing about these is that you're going to basically do the same thing for all of these. This one, you're going to plot the original, then 3 times bigger. Now, I'd like to do one with a fraction. Half would be fairly simple. A fourth, fairly simple, not too bad. Let's take a look at when it gets to be a weird fraction, like something like this. Okay, let's take a look at this one. So this one here, D, E, F, G. So let's start with our original. D is 0, 0. Now, this is my, notice the arrow right there. So 0, 0 is going to be right there. D prime. Or D, no prime. D. E is 2, 4. 1, 2. 1, 2, 3, 4. E. Okay. F, 6, 2. 1, 2, 3, 4. We're going to assume there's a line missing there. So 1, 2, 3, 4, 5, 6, and then it was 2, 1, 2. There is F, and then G is 4, negative 2. 1, 2, 3, 4, down 2, and there's G. And we will connect our dots. D, E, F, and G. Okay. Now let's switch to red in order to do this right here. Now, if you go, I don't know how to multiply times 5 over 2. Okay. A way that you can do this is when you're multiplying times 5 over 2. So let's take, for example, F. Okay. So if I'm doing 6 times 5 over 2, nice easy way to do this is to do the times the top part and then divided by this part. So I could do 6 times 5 and then divided by 2. Okay. So 6 times 5 is 30. 30 divided by 2 is 15. So point F, when I do 6 times 5 halves, it's 15. 2. 2 times 5, right? We'll do 2 instead. 2 times 5 is 10. 10 divided by 2 is 5. G. 4, right? Put a 4 there. 4 times 5 is 20. 20 divided by 2 is 10. Negative 2. Negative 2. Negative 2 times 5 is negative 10. Negative 10 divided by 2 is negative 5. Go back up to the top. 0 times, right? Put a 0. 0 times 5. Well, it's just going to be 0. Right, 0. 2, right? 2 times 5 is 10. 10 divided by 2 is 5. And then 4. 4 times 5 is 20. 20 divided by 2 is 10. Okay, I know I talked through those fast. Feel free to re-listen to that if you were confused by that. Or, hey, use your calculator. All right, D prime, right where the original D is at. E prime is 5, 10. So 1, 2, 4, 5. 1, 2, 3, 4, 6, 7, 8, 9, 10. Here's my new E. F is 15, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Up 5. 1, 2, 3, 4, 5. There's my new F. And then my new G is 10, negative 5. And so 10, so 1, 2, 3, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5. New G. And we'll connect those dots. So this process takes a little bit of work, but it's not really hard to do this because we're just multiplying numbers to get the new numbers. Okay. All right. So there you go. There you go. All right. When it moves to these questions here, where it doesn't give you the original points, the easiest thing you do is just find those original points. What are they? And then multiply by 2. Okay, you can do that. But let's see here. Let's go down to the bottom here. Identifying the scale factor. What do you do here? This is the last type of question that you're going to have to deal with. So let's talk about how you identify the scale factor. Okay. I'm going to look at just one now. Now this one here, or I need to look at both these, right? This one here, notice the original is small, the new one is big. So this is going to be an enlargement. So number bigger than 1. Okay. If I looked at this point W, let's see, here's this negative 1, it's back 2, right? No, I'm not going to worry about how high, I'm just going to, it's from here, it's back 2. This W is, let's see, 1, 2, 3, 4, 5, 6, 7, negative 8. So it went from negative 2 to negative 8. How many times bigger is that? What do I multiply negative 2 by to get a negative 8? Wouldn't that be times 4, right? It's 4 times bigger. Now, this can be challenging, and this is one that I think if you have questions, please feel free to ask those. I think I can help more individually, but honestly, that's all you're doing. Another way you could do that is take the new number divided by the original. 8 divided by 2 is 4. Okay, let's take a look at this one. Now this one's a reduction. The original is, let's go with this E. The original 1, 2, 3, 5. It's all the way out here at 6. The new one is 1 over here at 2, right? So you could actually do the same thing I did over here. Notice the thing that I did over here at the very end, the thing I mentioned at the very end was I said you could take the new number, right, in this case, which is a -8, and I could divide it by the original, which was a -2. -8 divided by a -2 is negative or +4. Now here's the nice thing. If you're paying attention, I wonder if the same thing would work over here. It's a third the size, right? But you go, oh, what does that mean? Well, let's do the same thing. The new, in this case, the new one is this 2. Is a 2, right? What's the original? 6. Notice I'm not even dealing with the whole coordinate. I'm just dealing with one part of a coordinate, right? 6. 2 over 6. If you try to do 2 divided by 6, it'd give you a decimal. If I just simplify this, isn't that 1/3? Okay. Well, I know that's a lot to take in, a lot of math you got to do, but I think you can do it. If you have any questions, please feel free to ask me, and I will do my best to help you out.